In our last video, we practiced doing this chemical equation. I asked you to complete the other chemical equation, so let's go over those answers. Here is sodium chloride plus fluorine yields sodium fluoride plus chlorine. Go ahead and write down this chemical equation on your extra sheet of paper. Once you have done that, let's go ahead and start an inventory. We're going to separate our reactants from our products, and then we're going to start listing our elements. I see sodium and chlorine and fluorine on my reactant side. I'm going to make my list the exact same way on my product side. So I have sodium, chlorine, and fluorine. Now I'm going to count them. On my reactant side, I see sodium. I don't see a subscript, so I'm assuming that there are only one. For chlorine, no subscript, so there's only one of these as well. For fluorine, here's our subscript. That means we have 2 fluorine atoms on our reactant side. Now I'm going to count them on my product side. Here's sodium, no subscript, so we have one of them. Fluorine, no subscript, so I have one of those as well. And then here's chlorine with a subscript of 2, which means we have 2 chlorine atoms. Alright, as I can tell, I am not balanced. I do have 1 sodium on each side, so that's good. When I look at my chlorines, I have 1 chlorine on my reactant side and 2 on my product side, which means that we are not balanced. So this is when we're going to place coefficients that are going to distribute, which means to multiply, in front of our chemical formulas. The easiest coefficient to place would be this 2 here. This 2 is going to distribute to the sodium and to the chlorine. Whenever I place a coefficient, I need to recount and fix my inventory. So putting this 2 here makes it so I have 2 sodium. So I'm going to mark this out and I'm going to rewrite a 2. Putting this 2 here is distributing to the chlorine, which means I now have 2 chlorines. Okay? So by placing this coefficient here, I've changed my number of sodiums, so let's fix it on our product side. I have 1 sodium here and I need 2. The only way I can fix that is placing a 2 here. It's going to distribute to the sodium and the fluorine. Whenever I place a coefficient, I have to recount my atoms for my inventory. So now I have 2 sodiums and I have 2 fluorines. I'm going to double check my work just to make sure. On my reactant side I have 2 sodiums. On my product side I have 2 sodiums. On my reactant side I have 2 chlorines. On my product side I have 2 chlorines. On my reactant side I have 2 fluorines. And on my product side I have 2 fluorines as well. Therefore, this equation is balanced. Let's look at the next chemical equation here. I have lead 2 nitrate plus potassium iodide yields lead 2 iodide and potassium nitrate. I'm going to give you a second to write this down. Make sure that you include your blank spaces for your coefficients. Once you've written it down, we are going to do our inventory. Alright, and for this chemical equation, I am going to use MINO. We covered MINO in the last video. MINO is an acronym for the order in which you should balance your chemical equations. Remember, M is for metals, I for ions, N for nonmetals, O for oxygen, and H for hydrogen. We save oxygen and hydrogen for last when we are balancing. Okay, so when I'm looking at this, I do see metals and I do see ions. Here is a polyatomic ion of nitrate. And I'm going to look on my product side and I'm going to see if I find nitrate, and I do. So when I'm making my inventory, when I'm making my list of elements, since nitrate shows up the same on both sides, I can include nitrate as one of my elements instead of separating the nitrogen and the oxygen. I'll show you what I mean. Alright, so I'm going to go ahead and start making my inventory. Here is lead. I have nitrate, which is NO3. Do not forget your 3. Remember, you cannot change your subscripts. I have potassium, and I have iodide. I'm going to make my list in the exact same order on my product side. Here's lead, nitrate, potassium, and iodine. Now it is time to count them. I'm going to go ahead and put parentheses around this nitrate, just so that I can remember that it is a group of atoms, and I'm not going to separate them. Okay, so here's lead on my reactant side. I do not see a subscript, so that means I have one of them. Nitrate, here's nitrate. Here's my subscript for nitrate. I have 2 of them. Potassium, no subscript, so I have 1. And iodine, no subscript, so I have 1. On my product side, here's lead. I do not have a subscript, so that means there's only 1 of them. Nitrate is over here. Okay, remember this 3 is part of nitrate, so I'm going to put parentheses around this. I do not see a subscript out here outside the parentheses, which means I only have 1 nitrate. Potassium, there's no subscripts by potassium, so I only have 1 of them. And iodine, here's my subscript, therefore I have 2. Okay? As I'm looking at this, I can tell that I'm not balanced. I'm going to look at my metals first. My metals are lead and potassium. In my inventory, lead is balanced already. Potassium is also balanced already, so as of right now, the metals are balanced. So let's look at the ions. I have nitrate is my only ion present. I have 2 nitrates on my reactant side, and I have 1 nitrate on my product side. It is not balanced. The easiest way to balance this is to place a 2 coefficient here, because I need 2 nitrates on my product side. Remember, when you place a coefficient, it's going to distribute to everything in that chemical formula. And when I place a coefficient, I have to recount in my inventory. So this 2 distributes to the potassium. So now for my potassiums, I have 2 of them. This 2 distributes to the nitrates. So now I have 2 nitrates. So by placing this coefficient, I have changed my number of potassiums, which is a metal. Therefore, I'm going to go back onto my reactant side and make it so I can have 2 potassiums here. The easiest way to do that is to place a coefficient of 2 in front of potassium iodide. Remember, this 2 distributes, so it's going to the potassium and the iodine. And when I place a coefficient, I have to recount. So my potassiums, now I have 2. And my iodines, I have 2 as well, because my coefficient here is distributing to the iodine. So my metals are now balanced. My ions are balanced. Let me look at my nonmetals. My nonmetals would be iodine. I have 2 iodines on my reactant side, and I have 2 iodines on my product side. Therefore, they are balanced. I do not have any hydrogens. And then this oxygen we included in the nitrate, so it's balanced as well. Remember, for these blank coefficients, we have our ghost 1. It is there. You just cannot see it, and we do not have to write them down. So good job. You have a couple more to do on this slide, and you can email me those answers, and we are going to continue on and take it to the next level. We're going to talk about word equations next. Okay, so the equations you have been seeing currently have already been made for you, so they're already in the form of formulas. Sometimes, though, you'll come across a word equation where you will have to write the chemical formula for the reactants and the products. When you're doing this, make sure that you're watching out for ionic compounds and covalent molecules. Remember, for an ionic compound, you have to have a metal and a non-metal. For a covalent molecule, you're going to have 2 or more non-metals. The easiest way to identify these in a word equation is you're going to have prefixes for your covalent molecules. When you are writing your chemical formulas, remember when you're doing an ionic compound, you have to make sure that your charges balance out to equal 0. So you'll need your periodic table with your periodic table trend printed on it to help you with your ionic compounds. For a covalent molecule, remember you have your prefixes that tell you how many of each atom there are in that formula. Just watch out for your diatomic molecules. 777, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. Okay, so just watch out for those. Then after you've written all your chemical formulas, you can set up your equation and then you can balance it. So let's practice a couple of these. We are going to write and balance the following equations. We're going to start off easy. Okay, so here's number 1. We have potassium oxide combines with water to make potassium hydroxide. The easiest thing to do is to decide whether you have ionic or covalent first. I have potassium oxide. Potassium is a metal and oxygen is a non-metal, therefore we have an ionic compound. With ionic compounds, I need to know the charge of each atom. So here's potassium. Potassium symbol is K. It is in group 1, so it has a +1 charge. Oxygen symbol is O. It is in group 16, so its charge is -2. It says combines with. Combines with will be your plus sign. Water. We all know the chemical equation for water is H2O. Where it says to make, that is your yield sign or your arrow. Remember, the arrow means to yield, to make, form, produce, create. Those are some common words you might see. And then we have potassium hydroxide. Again, we have a metal, and now we have hydroxide, which is a polyatomic ion. So this is an ionic bond. So I'm going to just repeat what I did before, and I have potassium with a +1 charge. And then I have hydroxide, which is OH, and the charge for hydroxide is a -1. So I've gone through this chemical word problem, and I've deciphered what each element is, if they are ionic or covalent, what their charges are. I've also decided where my plus sign goes and where my arrow goes. Now it's actually time to write out this chemical equation. So I'm going to do potassium oxide first. The correct formula for potassium oxide is K2O. Combines with is our plus. And we have water, H2O. We'll make, so that's our arrow, potassium hydroxide. Those charges balance out to equal 0. So I don't need any extras, so I'm going to write KOH here. So here's our chemical equation, and now we're going to see if it needs to be balanced. I have 2 potassiums on this side, and I have 1 potassium on that side. That's a clear indicator that it's time to balance this chemical equation. So I've split my equation into 2, and I am going to do my inventory. I have potassium, oxygen, and hydrogen. Potassium, that's okay. Oxygen and hydrogen, and now I'm going to count them. I have 2 potassiums on my reactant side. And now our oxygens are a little tricky here. I have oxygen located in 2 places, so I have O plus O, that's 2, and I have 2 hydrogens as well. Okay, I'm running out of time on this video, so I'm just going to quickly do this. We only need 1 coefficient, and it is a 2 here.